Hello students, let us continue with class 9 chapter number 1 module number 3, that is matter in our surroundings. The topics which we are going to cover today are differences between states of matter, various states of matter like solid, liquid and gases. Can matter change its state? Melting point, boiling point and latent heat. Degree Celsius and Kelvin scale. Differences between various states of matter. Talking about the solid, the interparticle spacing is very negligible, I can say, and therefore the bond between them are very strong. But talking about the liquid has spacing between them. The intermolecular space is more than solid and hence the slight mobility is possible. Hence liquids flow and has a fluidity, that is ability to flow, and hence even the particles, the bond, the interparticle bond is again lesser than solid. It is not very intact, not very rigid, but it is movable or can slide on each other. Talking about gas, the particles are very far apart from each other. Interparticle distance is far, hence the bond, the particular attraction is very less, I can say negligible also sometimes. And even the same time the particles has lot of space, the interparticle space between them. This has been explained very well in the previous module, so go through this very carefully and prepare a notes. In case of any doubt, reach me through Google Classroom or any other source. Can matter change its state? We all know from observation that water can exist in three states of matter: solid as ice, liquid as the familiar water, and gas as water vapor. Effect of change of temperature. How does the temperature change? The particular states of matter is affected by the change of temperature. Talking about this activity, the demonstration, here the ice is kept, thermometer is placed, okay, thermometer is placed and glass rod for continuous stirring. Here when heat is given, the ice starts melting and it changes into the new state called as liquid state. In the second case, the water, liquid water is again more heating is given, where the temperature increases and the same time the liquid changes into the vapor form. In either of the case, there is a change in kinetic energy of the particles. Due to the change in kinetic energy in the solid, the particles start moving away from each other, hence the bond becomes loose as we have seen in the previous slide, and at the same time it has a tendency to flow and becomes a liquid. Same way the liquid, whatever the molecular strength they have, starts breaking due to more kinetic energy. The particles starts moving away from each other and just move apart and convert into the gaseous form, that is having a maximum kinetic energy in the case of gaseous form, that is a water vapor form. Okay, so this is an example of conversion of ice to water due to the increase in kinetic energy due to the temperature increase, that is which affects the kinetic energy. Even conversion of water to water vapor due to the increase in temperature. On increasing the temperature of solids, the kinetic energy of the particles increases. Due to the increase in kinetic energy, the particle starts vibrating with greater speed. The energy supplied by the heat overcomes the force of attraction between the particles. The particles leave their fixed position and starts moving more freely. A stage is reached when the solid melts and it is converted into a liquid. This way the solid gets converted into liquid. Let us understand what you mean by melting point. The minimum temperature, the minimum temperature at which a solid melts to become liquid at the atmospheric pressure is called its melting point. It is a temperature, it is a fixed temperature at which the pure liquid, the solid changes into its liquid form, and that is called its melting point. Latent heat of fusion. What do you mean by latent heat of fusion? Latent means a hidden heat of fusion. That is the while melting, the hidden heat which is utilized, which does not increase the temperature rise, is this, that is called as latent heat of fusion. The amount of heat energy that is required to change 1 kg of a solid into liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. What's the difference between melting point and latent heat of fusion? Latent heat of fusion is a stage where the heat is given, the temperature is not increased, not notified by the thermometer, but at the same time the heat is absorbed, which is used to convert that particular one state of matter to the other. That is called as hidden heat or latent heat of fusion. Now talking about boiling point. The temperature at which a liquid starts boiling at the atmospheric pressure is known as its boiling point. Means at the temperature at which liquid starts converting into vapor, and there is a constant reading in the temperature thermometer is called boiling point. Latent heat of vaporization. What do you mean by latent heat of vaporization? The amount of heat energy that is required to change 1 kg of a liquid into its vapor state at atmospheric pressure at its boiling point is known as latent heat of vaporization. Here, whatever the energy required, here again I can say latent means the hidden heat. Here again, while the temperature is increasing on the thermometer due to the continuous supply of heat, there is a stage when the liquid starts converting into the vapor, and at this stage, till whole liquid is converted into vapor, the particular temperature in the thermometer remains constant, and that heat which is continually absorbed is not indicated by thermometer. Why? Because this heat, whatever is continually given, is used to convert liquid into gaseous form or the vapor form, hence unnotified heat or hidden heat. This heat, whatever is used, is called latent heat of vaporization. Let us understand better by using the graph. Here in the graph you can say this is a temperature in degree Celsius. Heat is added continually. Here heat is added to the solid, and there is a stage which is called as latent heat of fusion, where you will not see the rise in temperature at all, but still the heat is given, and hence heat is continually given, and but this is used to convert solid into liquid. Hence, this is called as latent heat of fusion, because the temperature rise is not notified by the thermometer. Again, after this, it converts into totally a liquid form. This liquid again, when the more heat is given, as soon as the heat is increased, the liquid states start converting into vapor, but till the stage liquid start converting into vapor, the heat is given, but it is not notified by the temperature, because that is an hidden heat over here, and it is required to convert the liquid into vapor state. And after that, whatever the gaseous form, they start increasing with the temperature, because they have more kinetic energy, due to which more temperature is indicated. So this graph indicates or explains you well about latent heat of fusion and latent heat of vaporization. Now this is very clearly shown here. Solid state, when you heat, it converts into liquid. Again you heat the liquid state, it will be converted into gaseous state. Again reverse back, that is removing the heat or cooling, again it converts into liquid. More you cool it or remove the heat, that is, it will convert into solid state. That is a interconversion between the states of matter. Note, Kelvin is the SI unit of temperature. 0 degree Celsius is equal to 273.15 Kelvin. For convenience for calculation, we take 0 degree Celsius is equal to 273 Kelvin. Kelvin never will write as a degree Kelvin. Only Kelvin is notified. For degree Celsius, we are mentioning as a degree. Let us have a look on the calculus of temperature while it's conversion from one scale of temperature to the other. When you want to convert the degree Celsius into Kelvin scale, you have to add 273, as already 0 degree of temperature in degree Celsius is equal to 273 Kelvin, which is a difference between Kelvin, and that is a difference between Kelvin and degree Celsius. Hence, for converting degree Celsius, which it will be requiring addition of 273, and after adding you can make it into Kelvin Celsius. Same in this case, we are adding 273 to 678 degrees Celsius. Hence, in Kelvin scale, the temperature will be 951 Kelvin. Even converting Kelvin scale into degree Celsius scale, here again you have, here we are adding, but here Kelvin to degree Celsius again lower amount, you have to reduce it by 273. Okay, so 278 Kelvin will be minus 278 will be giving you 5 degrees Celsius. The same time here, for converting 48 Kelvin into degree Celsius, 48 minus 273, which will be minus 225 degrees Celsius. Hope you understood this conversion. Let us go with the practice work 3. Define latent heat of vaporization. You can mention the example 2. Latent heat of fusion. Convert the following into degree Celsius. This 2 you have to solve it, and already I have explained in the last slide. Expand CNG and LPG. What do you mean by this? You can have the full form and you can elaborate in your word. What is boiling point? Thank you, all of you.